Hello guys, welcome to Examalist. So in the next question, you have been given a series of masses. So you see these black dots here. All these black dots, they represent the mass. And this mass is connected through a spring of spring constant K. Okay. So now the question is, what will be the correct Lagrangian for this type of system that contains n masses all connected with each other through a spring? So to frame the Lagrangian, I would like to focus your attention towards the nth particle. Consider the nth particle, and during the motion, tell me what will happen, what will cause the motion? A displacement of this nth particle, let this be qn. Okay, so this displacement will create a restoring force, but we were taking this kind of displacement and we were directly using, so for example we have one particle system and I displaced it by say a distance x. Okay, so in this case say I displaced it by a distance qn, then I can directly write my force equals to minus k into displacement qn. But the problem is I cannot write this here because there is another, this is connected with another mass here. So the net force on this nth block depends on the net stretching. Consider this block is stretched by q n plus 1. Okay, so the net stretch means I'm considering the stretch in between the two objects. I'm not considering the stretch here. Okay, there is a very subtle reason why we do this, but maybe you try to think it out. It's not that tough because you see there is another mass here in our question, so that's why we focus on the net displacement in this part. Okay, anyways, so the real force should be written for the nth particle, that is the force on nth particle is minus k. What is the net displacement that creates force on the nth particle? The net displacement that creates the force on the nth particle is q minus 1, q n plus 1 minus q n. So the displacement of n plus 1th particle minus the displacement of the nth particle will give me the net displacement. Okay, now this net displacement is responsible for forces. Agreed? So if I ask you what is the potential energy of this nth object, okay, then what would you answer? You would answer that the potential energy will be half into k into net displacement square. What is the net displacement of this q nth particle? It is q n plus 1 minus qn, so this is net displacement square. If I ask you what is the kinetic energy, you'll say, hey, kinetic energy will be half into mass into velocity square. So what is velocity? Velocity will be qn dot square. It's very easy. So this is the sum of so now Lagrangian is kinetic minus potential, so I choose a minus sign. Okay, let me choose the minus sign here. So this is the Lagrangian of the nth particle. To write the complete Lagrangian of all the particles, what I need to do? I need to just make a sum. The n sum will go from n equals to 1 to capital N. Capital N is the number of masses, and here the potential energy will also go from n equals to 1 to capital N. That's it. This is the Lagrangian of a system of n discrete point masses connected to each other through a spring. Okay, it was very easy. I hope you got the Lagrangian. But this is not the end. We need to solve this Lagrangian equation of motion. Okay, so that's an interesting thing to do. So let us solve the Lagrangian equation of motion for the nth particle. So can I write the Lagrangian equation of motion, which is d by dt? We have already discussed the things in our theory lectures in great detail. So this will be del L by del which one? So let me make the Lagrangian equation of motion for the nth particle. minus dl divided by dqn, okay, dqn equals 0. So this is the Lagrangian equation of motion for the nth particle. So let's try to solve it. Oh, so here we have a q dot. So in this Lagrangian, tell me which term is only a function of q dot. So only this term is a function of q dot. So I don't want to consider the summation because I'm doing for the nth particle. So I want to consider only this much of term. So first term will be d by dt of, okay, del by del q nth particle dot, okay, what is L? L is t minus v, okay, but I am only considering this particular term because only this particular term in the entire Lagrangian is a function of q dot. Rest everything will go to 0. So here what should I write? I should write half into m into q nth particle dot square. So this is Lagrangian of the first term. Now what we have to do? Now we have to do d divided by dqn. Now what we should do? What we should write here? You see, this is a function of q dot. So d by dq of this part will be 0. We need to focus only on the second point. So in the second point, we need to focus how many qn's are available. So since this is a sum from n equals to 1 to n, qn will be only available in term q n plus 1 minus qn square. So this is a term that will contain qn, but there is one more term that will contain qn. So that will be plus, the another term will be qn minus qn minus 1 square. Only these two terms in the entire sum will contain the qn. So now if you expand it, what you'll get? You'll get qn plus 1 square plus qn square, and there will be minus 2qn plus 1 and qn. So this is the expansion of the first term. Now the second term will be qn square, then plus q and minus 1 square. As usual, there is a minus sign, to qn minus 1. So in the entire sum, only these term will have qn. But what we need to do? We need to do d by dqn. So what will d by dqn of this particular term will give? Let's try to find. Here there is a qn, so this will be 2qn minus, here there is a qn, after derivative you will get 2q n plus 1. Here there is a qn, so this will fetch me 2qn, and minus, here there is a qn, I'll get 2qn minus 1, and there is no other term that contains the qn. So this is after the derivative. So I actually solved the derivative. So can I just write the result here? Okay, since I solved the derivative, I can easily write the result here. So what is the result? The result will be minus of, now this entire thing will contain a minus sign at the outside because of this minus sign. We didn't include this minus sign, so this minus sign will be at the end. So what will be your net result? Your net result will come out to be, there will be a plus sign here, this minus and this minus will give you a plus. And what are the terms that we need to write here? We can write 2 qn minus 1, qn minus qn minus 1, and then I can take a minus sign and I can write 2 qn plus 1 minus qn n plus 1 minus q n. Okay, so this is my Lagrangian equation of motion. So what will be the final answer of the equation of motion? The first term, as you can easily do the derivative, will give you m q n double dot. Okay, and the second term will have k by 2. Remember, there is a k by 2 that we must mention here. So in the end, not only there will be a minus time, but also there will be a k by 2. So k by 2 in bracket, what will happen? If you look at it carefully, then let us see which term they get cancelled. Nope. Here we can have 2qn. So here you see 2qn and 2qn, so that will give me 4qn. So let me write 4qn plus, no, there won't be any plus, with a minus of q and minus 1. So there will be q and minus 1 minus of q and plus 1. Okay, now can I rub it? I think you might have understood this part, so there is no use of writing this. I can rub. Okay, so all of you understood how to evaluate the Lagrangian. Okay, so this question is of special importance here, and I will tell you why I'm solving this. Okay, so finally, what do you get in the equation of motion? So remember that Lagrangian equation of motion, this entire thing is equals to 0. So this entire thing is equal to 0. So let me write what is the equation of motion. The equation of motion is m q n double dot equals k. Okay, all the two terms, they will cancel. See, if you remember, there was a 2 here, I forgot to write, and there was a 2 here. Okay, everybody had a 2. So the 2 will cancel, and what we'll have at the end? In the end, we'll have q n plus 1 plus q n minus 1 minus 2qn. Okay, so this is an important result that you need to remember. So this is the Lagrangian equation of motion for the n particle system. Okay, and this is the Lagrangian of the n particle system. Okay, now we have this question where it is said that what will be the Lagrangian equation of motion in continuum limit. Okay, so what is the meaning of continuum limit? Continuum limit is when the distance between two objects, two masses, it was a. What if a goes to 0? Continuum limit means when a goes to 0, all the masses are very closely placed to each other. So when all the masses are very closely placed to each other, then instead of defining discrete positions like qn, qn plus 1, so instead of defining discrete positions in a continuum limit, I can define a position which will be a function of x. The reason I got a function of x because there is a continuity along x direction. I do not have discrete points. Why don't I have discrete points? Because I have assumed that all the masses are very close to each other. Okay, so now I'll do a very interesting proof. The interesting proof here goes, I want to prove that this part, okay, will give you something interesting. So now what I'll do is I'll prove to you that q n plus 1 minus 2qn plus q n minus 1 whole divided by a square becomes second derivative of, so second spatial derivative, qx. Okay, this side is the continuum limit and this side is the discrete system. So now I need to prove this to you. Okay, how can I have this thing equal to this thing? Okay, the proof is quite straightforward. So let me do it here. So d by dx of q of x. So what is this? This can be written as q x plus delta x. Okay, delta x is the distance between 2 points, minus q of x divided by delta x. Okay, now now I do second derivative. So for the second derivative I need to do d by dx of this term. So now what I have d by dx of q x plus delta x minus q of x divided by delta x. Okay, so how to do the derivative? 1 by delta x will go outside since this is the interval which is constant. So I will have two things. I will have d by dx of q x plus delta x minus d by dx of q of x. Okay, let's try to do this. So 1 by delta x will go outside. So in the second term, everywhere there will be a delta x. So let me write. So what will be the first term? So the first term will be q of x plus 2 delta x. So I increase a delta x again, minus q of x plus delta x. Okay. Second, we have another term minus of, what is the first term? Now I'm evaluating this part. This will be q of x plus delta x, and there will be a minus and that will become a plus. So this will be q of x. Okay. So now what do you get? You get q. Now what is x plus 2 delta x? 2 delta x means, say if you are at nth position, okay, so consider, if you consider this as the q n plus 1 at position. Okay, so let me write it down. So consider this is q n plus 1 minus, so this will get added 2 into, so this can be written as qn. Then what will be this? This will be qn minus 1. What is delta x? Delta x is nothing but a, that is the interval. So here I will get what? I'll get a square. So you see, if I do the derivative of this twice, I get this. Okay, so returning to our question, what will this equation of motion look in a continuum limit? In a continuum limit, this will become a wave equation, because look at this. We have m d q n. So double dot means twice time derivative. So we have a special, we have a time part here equals. So if I multiply k a square, so if I multiply a square here and put a square here, then what do I get? I'll get, so maybe I can do partial derivative. So this will be nothing but partial derivative square with respect to x into dqx. Now, slight thing, this will not become qn because you have replaced all the qn by a function, because in continuum limit you do not have discrete points, so you don't need to define this point is n, this point is n plus 1. You don't have to do this. Discrete points have become continuous, means they are very close to each other. So for example, how do you define the mass of the rope? You define the mass of the rope by defining a quantity which is length per unit, mass per unit length, lambda. And this lambda is directly a function of x, because when you are considering a rope, the mass is continuously distributed in the entire x. That's why this part will become q of x. Okay, so if you look at this equation closely, you will get a wave equation. So under continuum limit, n particle system behaves like a continuous system, and they give you a wave equation. So let me write down the wave equation. So the wave equation is this. So I can simplify it a bit. Okay, and this will become 1 by v square d square q as a function of x divided by dt square equals the space part. What is the space part? This is d square by dx square into q of x. Okay, so from here all of you can know what velocity is. Okay, velocity will be in terms of a square, k and m. So let us try to figure out velocity. So it seems like the velocity will be root over of k a square divided by m. Okay, so for your convenience, let me give a bracket here. Okay, now let's take a quick review of what the question was and what have we learned. The question was saying we have an n particle system and write the Lagrangian. We have written the Lagrangian here. Then the question says for this n particle system solve the equation of motion of Lagrangian. Here we have solved the equation of motion of Lagrangian. These two things looks quite unintuitive. It doesn't look intuitive, but it becomes intuitive when you look at the continuum limit. So what happens when you have n small particles connected through spring? You have this weird equation of motion. But the moment you reach the continuum limit means all the masses are very close to each other, because in the continuum limit we define the interval a goes to 0. So when the masses are very close to each other, this is similar to saying that we have a straight wire or straight rope. And what is the equation of motion for a straight rope? The equation of motion for a straight rope is the wave equation, and here we have got the wave equation. Okay, so now you understood. Now why this question was very important? Why do you need to learn this? There is a very important thing that I need to mention here. In future, if you ever study something called as quantum field theory, then you will learn that the fields, for example electromagnetic field, can be defined as a collection of harmonic oscillators. This system you can say as a collection of harmonic oscillators, and the equation of motion for the electromagnetic wave turns out to be same as the equation of motion of the n particle harmonic oscillator, because in the n particle harmonic oscillator you get a wave equation. Similarly, in electrodynamics, you have the wave equation with yourself. In this way, we found a connection between electric field, I mean electromagnetic wave, and we were able to define these kind of fields like the electric field or magnetic field as a collection of harmonic oscillators. So that you will do when you will study those type of subjects. But here I hope you understand. Let me give you a quick review. Review number one, we have a particle, we have an n particle system, and we wrote down its Lagrangian. We were asked to find the equation of motion for n particle system, and we wrote down the equation of motion here. And then we were asked to find what will this equation of motion look in a continuum limit, and we also wrote that this equation of motion in continuum limit will have a wave equation, will look like a wave equation, because which is quite obvious. In a continuum limit, instead of having n particle system, you'll have a straight rope, and the only thing we have in a rope is a wave. Okay, so I hope you enjoyed this question, though it was a very long question, but I hope you learned a lot of mathematics here, how to do, how to solve the Lagrangian equation of motion for discrete points. Sometimes questions might come, so you have to be very careful when you solve the mathematics. Okay, so in the next lecture we'll discuss more.